sigma bonds and pi bonds. Differentiate between sigma bonds and pi bonds. Differentiate sigma bond, pi bond. Okay, differentiate between sigma bond and pi bond. Sigma bond is denoted by sigma, like this notation, like this symbol. Sigma bond is denoted by. Pi bond is denoted by like this. Okay. Next, second point is sigma bond. In the case of sigma bond, axial overlapping or end-to-end overlapping takes place, or axial overlap or end-to-end. In the case of pi bond, lateral overlapping or sidewise overlapping take place. Okay. Next, third point, since in the case of sigma bond, axial overlapping takes place, the bond is strong. Strong bond formation takes place. In this case, pi bond, weak bonds are formed. Okay. Next, fourth one, since the bond is strong, they are less reactive. And in the case of pi bond, they are more reactive. Okay. Now, the fifth point is, in this case of sigma bond, SS, SP, PD, etc. overlapping takes place. Okay. SS, SP, PD, ST, etc. overlapping takes place. But in the case of pi bond, PP, same kind of orbitals overlap. PP overlapping takes place. Okay. Next, sixth point. In this case, AC rotation is possible. AC rotation is possible. But in the case of pi bond, restricted rotation is taking place. Restricted to rotation. How it is restricted to rotation? Because in the case of pi bond, sidewise overlapping of p orbitals are taking place, and these p orbitals are perpendicular to the plane of the molecule. Okay, these p orbitals are perpendicular to the plane of the molecules, or the pi bonds are said to be delocalized above and below the plane of the molecule. Okay, pi bonds are delocalized above and below the plane of the molecule. So there will be an electron cloud is formed above and below the plane of the molecule. So due to delocalization, pi bonds are restricted to rotate. Okay, there is restricted rotation in the case of pi bond. Also, we know that due to delocalization, there will be an electron cloud is formed above and below. So these electrons are easily available for the chemical reaction. So they are also called as reactive centers of multiple bonds. Okay, they are also the reactive centers. These are the differences between sigma bond and pi bond. Okay. Now, next, let us calculate the sigma bond and pi bond. Calculation of sigma bonds and pi bonds. Calculation of sigma bond and pi bond. How can we calculate? Total number of pi bonds in a molecule. Sigma bonds. Total number of sigma bonds in a molecule will be equal to the total number of atoms present in the molecule, total number of atoms in the molecule minus 1. This will be the formula. Total, this will be the easy trick to find number of sigma bonds. Total number of sigma bonds in a molecule will be equal to the total number of atoms present in the molecule minus 1. Okay. How can we calculate the number of pi bonds? That we know that if there is a pi bond, if there is a double bond means there will be one pi bond, and if there is a triple bond, there will be two pi bonds. Okay. Now let us calculate one by one with examples. First example, calculation of pi bond. First example is, take this example. First one, CH triple bond CH, okay, double bond CH3. Take this example. So total number of pi bonds, total number of sigma bonds. First, total number of sigma bonds. Total number of sigma bonds will be equal to, how many atoms present in the molecule? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So 11 minus 1, that's equal to 10 sigma bonds are present. Okay. 10 sigma bonds are there in the molecule. How can we calculate the pi bonds? Number of pi bonds. Number of pi bonds will be equal to, how many? Here 2 pi bond and here 1 pi bond. So 2 plus 1, 3 pi bonds are there. Okay. Now, how can we calculate next molecule? Next molecule is CH3, okay, CH triple bond CHCl. How can we calculate the total number of sigma bonds? Total number of sigma bonds will be equal to 1 plus 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1, that is equal to 9 sigma bonds. Okay. Now, total number of pi bonds. Total number of pi bonds. Sorry, here, double bond. Total number of pi bonds will be equal to, we know in the case of CN, there will be a triple bond. Okay. So, how many pi bonds are there? 1 plus 2, 3. So, 3 pi bonds are there in this molecule. Okay. 3 pi bonds are there. Now, let us take another example. Third one. Third one. C double bond OH. Okay. Now, NH. How many sigma bonds? Total number of sigma bonds will be equal to 1, 2, 3, 4, 5, 6. 6 minus 1, that is equal to 5 sigma bonds. Okay. Now, total number of pi bonds. Total number of pi bonds. How many pi bonds are there? It's only 1 pi bond. Okay. Now, let us see a benzene structure, a ring structure. Fourth one. Consider this as an example. Take this compound. C double bond O H. Okay. C double. Consider this compound. In this case, we know that 6 carbon atom. Okay. 6 carbon atoms are there. Okay. And 1 hydrogen atom here. Okay. 1 hydrogen atom for each carbon atom. Now, it's okay. How many atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, total number of sigma bonds equal 14 minus 1. That is equal to 13. Okay. Now, total number of pi bonds. Total number of pi bonds will be equal to, check. Here one pi bond, 1, 2, 3, 4. So, 4 pi bonds are there. Okay. Understood? Okay. This much about the calculation of sigma bonds and pi bonds.